This conference will now be recorded.
Hello everyone, welcome to our review session. So this is the review for the exam 2, but please note this is only a brief review of the things we have done so far. So don't only rely on what I do here. So as I advised you earlier, you should go through all the homework questions and all the theory parts if you want to do this. I mean, if you are trying for a good grade in this exam. Right, okay, so let's start. Now we first discussed about linear functions. That's the functions that looks like this, mx plus c. So they are basically straight lines. Now here I'm not going to do like lot of specific problems, okay? I'm just giving you a summary of the things we have done, okay? And doing problems is up to you. I consider it as your responsibility, and also you can always come and talk to me if you have any questions, okay? So here we have a straight line, and this is considered as the slope, and this is the y-axis intercept. If you have a negative c value, you have the intercept in here, and if the value of m is greater than 0, the line will look like this, and if it is negative, you will have an inclination like this. So basically, on if they give you a slope and an intersection, you should be able to write down the formula of the straight line, okay? And also, if they give you a straight line, a diagram of the straight line, something like this, you should be able to extract out the suitable y-axis intercept, which is considered as the c value in the formula mx plus c, and then you should know how to calculate this m value. Remember that m value is considered as the tangent value, so you just need a rectangle and this angle, okay? And not actually the angle, but the tan value of that angle, and the tangent value of a right angled triangle is defined by this opposite side divided by the adjacent side, okay? So that's what we need, the opposite side divided by the adjacent side. So we need this length divided by this length. Getting the triangle anywhere in the line is okay as long as it is a straight line. So instead of picking some random position, just choose a right angle triangle where you know the measurements. Okay, so you will get this height and this length, divide them by each other, you will get the slope, or basically the m value. Likewise, you should be able to determine the slope and then the intersection to get the formula for the straight line. Okay, and as I mentioned earlier, I'm not doing any specific problems. Okay, I have done plenty of problems like this in the class, and also you have like lot of practice problems in the homework. And then we move to quadratic functions. We did an extensive study on quadratic functions. They are the functions that look like this, and the main shape of the curve is a parabola, okay? So the location of this parabola will depend on these a, b and c values calculated in a suitable manner, okay? So when it comes to parabolas, we did several things, okay? So this is the lesson we covered under parabolas, quadratic functions 4.3. So we introduced it, and first we checked what happens if you with respect to this a value, so the shape will kind of it sort of expands or stretch along the y-axis, and then we should be able to determine the shape depending on the formula, or in other words, if they have given us the formula, we should be able to extract out this vertex. There are a couple of ways to do that. So if they give you the formula, we should be able to extract out the vertex. Vertex means the coordinate at this turning point. Okay, it's called h comma k. So there are a couple of methods to do that. Like the easiest thing that can happen is this one. So if they give you the format like this, a times x minus h squared plus k, then directly we can extract out the coordinates of the vertex. Okay, you can directly extract out the coordinates as h and k. Be careful, here you have a negative in between, so if it was a positive, you should get the numbers correct, I mean appropriately. Once again, we have done so many problems like this, so please check those questions if you need more practice. And then so once you get the vertex, you should be able to kind of get a brief idea about how this parabola will look like, because depending on the positive or the negative nature of this a, parabola will look like this or this. And now if we know the values of h and k, we will have the coordinates of the vertex. Okay, so accordingly we will know what the shape is, and then the only thing that is left is to figure out the x coordinates. And if they want, you can even calculate the y coordinates as well. So now finding the x coordinates and the y coordinates is not something which is unique for a parabola. It's common for any function. Okay, remember I did this in the class. So if you have any function like this, okay, so if you have any function like this, if I ask you to calculate these x intersections, what do you have to do? When I say x intersections, I am referring to the x comma y coordinate. And in all these x intersections, we know that the y coordinate is 0 and we need the x value. And also this y coordinate is given by the function value at this given x. Okay, in other words, this function value was 0 at this particular x, which is an unknown. So you basically have to equate the function to 0 and calculate the suitable x values that make the function 0. That's how you calculate these x values. And then if you want to calculate this y intersections, once again I am asking for a x comma y coordinate pair, and what we know here is, so you need to calculate x comma y. What we know is the x coordinate along this line is 0 and we need the y value. Once again, y value is basically the function value evaluated at a given x, and now we know that the x coordinate is 0, hence the y value is given by directly substituting 0 into the function. So this is the y value. So no matter what function you have, say something like this, x squared plus 3x plus 9, you just have to work it out appropriately. Okay, right. And also we did a question like, if they have a parabola and if they ask you to determine points on the parabola, if you know the formula, you just have to, let's say something like this, you just have to pick an x value, substitute it into the formula, you will get the y value. So you get the x comma y coordinate, and you can do it for any given x, but it's better if you can choose some good numbers to avoid unnecessary simplifications. What I meant by that is, like, let's say if you choose something like 10.798, you will have to substitute this value into this formula, which makes it a bit more difficult to simplify. So just always try to pick some nice looking numbers like this. Okay, right. uh, and then also, when it comes to these parabolas, we did another thing called finding the vertex using the vertex formula. That is, so before that we kind of use this method of completing squares. That's again a very strong method. And then we did discuss this vertex formula. So basically, if you have a function, a quadratic function, write down these a, b and c values accordingly, and this or this will give you the formula for the vertex. Okay, so sometimes it will be easy to use this one, and sometimes it will be easy to use this one. And here you should notice that the x coordinate in both these cases are the same, and here y coordinate is given with respect to the given function, and here it's kind of given with respect to a, b and c values. So sometimes it is easy to use this one, and sometimes it is easy to use this one, and I recommend you to do these problems in the slide. So this theory of parabolas is a very important section, and it will carry some weight in the exam. So I highly recommend you to go through this lesson. And next, then in the next chapter, we learned several different functions. So we studied what happens to, we studied about power functions, that is functions that takes this form, x to the power some number. And as the first set of examples, we considered what happens, we considered, I mean, we pictured the graph when this number is a natural number, that is x to the power 1, 2, 3, 4, likewise. Now here actually x to the power 1 is basically x, so that is just asking for the graph of fx equals x, which is a straight line, okay, passing through the origin. So that's kind of an exception. Other than that, we are looking for values like x to the power 2, x to the power 3, x to the power 4, x to the power 5, things like that. So here, to get the graphs, we divided into two separate sections: x to the power odd numbers, x to the power even numbers. So this one, the examples we have is 3, x to the power 5, x to the power 7, and for this one you get x to the power 2, x to the power 4, x to the power 6, and so on. Now for this category, the shape was this sort of an S shape, okay, and for this it's the parabolic shape. And we did discuss what happens to this shape when the power increases. It kind of take this sort of a shape when the power increases, and a similar property is explained in here as well. So if you really want to try those diagrams, I recommend you to use this website, Desmos Graphing Calculator. So just Google this word, this one, just type Desmos Graphing in Google, and the very first link you have is the Desmos Graphing tool, which is a free online tool where you can use to graph these functions. So please use it when you practice, but you cannot use it in the exam. Okay, right. And then I'm still discussing about the functions, function types. The next one we thought was the graphs that has a shape like this. So x to the power, no, not x to the power, 1 over x to the power 1, 2, 3, likewise. So that's like 1 over x, 1 over x to the power 2, 1 over x to the power 3, 1 over x to the power 4, and so on. Okay, so once again we divided them into two sections: 1 over x to the power odd number, 1 over x to the power even number. And when it is odd, you have a graph like this. You have a graph like this. They never touch the x-axis. Okay, and when it is even, you have a graph like this. Okay, and finally we discussed about the cube, the nth roots, this one. So that's like this is the square root, cube root, fourth root, fifth root, and so on. And you can even rewrite this one as x to the power half, which is basically the square root that we are familiar with. So this one, for only this one, you don't need to write this 2 in here. So you can just write it like this, but for everything else you need to mention the number. So this is 1 to the power 3, 1 to the power 4, 1 to the power 5, and so on. Okay, so what about the graph? Again, we divide it into two sections: x to the power 1 odd, x to the power 1 even. Now, what about the graph? When it is odd, you have this shape. Okay, it's sort of similar to this shape, but in an inverted manner. Okay, and then when it is even, you have this. You don't have a graph on this side, no graph here. Okay, right. And then we discussed about a thing called piecewise functions, and we discussed several examples on piecewise functions. What you should know is it is a function defined into separate pieces. Okay, we segment the number line into different sections. So let's say we have the number line and we kind of partition it into separate segments. That's why it's called piecewise function. And on each of these segments we define a separate formula, and then we draw the graph according to the formula given for that particular section. Okay, so a very special piecewise function that we did was the absolute value function, which is defined like this. It's negative x, then this it is positive x. So when it is positive, you have the x, and when it is negative, you have the negative x. So if you take the two individual graphs, fx equals negative x, you have a graph like this. Let me draw that in a different color. And if it is f of positive x, fx equals x, that's going to be this one. Okay, it goes to 0. Now what we need is when it is less than 0, that is this side, graph behaves according to this formula, so this part. When it is greater, graph behaves according to this formula, which is this part. And here the endpoint belongs to this graph because of this inequality sign. You have greater than as well as equal, but that equation is not there in here. Okay, so that's basically the idea of piecewise functions, and we have done couple of problems in the class and they are on the slide as well, so please go through those questions. And one more reminder, now this review video is not at all the place to learn these stuffs. I'm just reviewing the things. I'm not explaining any like basic theory from the scratch. So this is not the place to learn these things at all. Okay, so if you want to learn these stuffs, you should go back to the previous lecture slides as well as the textbook to learn this. So please keep that in mind. I'm not teaching you the basics, I'm just reviewing them. Okay, right. And then, so that's about all the function types. And also like at the end of this section we did a thing called greatest integer function, but for this exam you don't have to worry too much about that greatest integer function. Okay, but I think for the homework I gave you like 1 or 2 questions on the greatest integer function, right? And then we sort of did what happens if you make changes or if you do transformations to given functions. Okay, there are like separate types of transformations that we did during our like last lessons in the previous week, I guess. Yes. So when it comes to transformations, we did a couple of different transformations. uh, the first one, so what happens in transformations is you have a function and you have a more complicated looking function that can be created using this basic one. Okay, by making some adjustments, right? So we have this transformation x minus h or x plus h. Like for example, if you take this one, if you add a value like this, it moves to the left. If you subtract a value, it moves to the right. So the shape of this graph is this one. Now guys, once again I want to stress this, I'm not teaching you the basics of transformation. Okay, so if this is the very first time you are seeing this, that this is not a good place to learn those things. Okay, so please go through the previous lessons that I did before coming into this preview video. Okay, so if you add, moves to the left. If you subtract, moves to the right. And then that's called horizontal transformations or horizontal shift. And then another one you can do is, another type of a transformation is you can add the number outside. So here the formula will look like this, or like this. Now here you will have the formula like this, or if you subtract, you get x squared minus 10. Okay, so for this it moves either up or down, right? And then we completed let me download that slide first. Okay, so we did horizontal shift, and see, it moves to the left and right. This is horizontal, and then vertical, the one that I just described. And you should observe how the domains change when you do this horizontal and the vertical shifting. And rather, like, for all the transformations that is happening around, you should observe how the domains change. So for example, if you think about this function, this is the domain. Okay, so if it moves couple of units to the right, then this becomes the domain. None of these values are included. Okay, and if you want to think about the range, this becomes the range. Here also this becomes the range. But if it moves up, so let's say if the graph moves up like this, now this becomes the range and this becomes the domain. See here, these two domains are equal but not the range, and here the two ranges are equal but not the domains. So it totally depends on the graph you have. So if you have a graph, how do you identify the domain? Domain is basically all the acceptable x values. So if you have something like this, for all these x values you have a corresponding y. So for the domain you include all the x values. But if you have, let's say, something like this, for these x values you don't have a particular y, so for the domain you exclude these x values. Okay, and if you have something like this, let's say if you have something like this, you can see for these x values you have a corresponding y, but for x equals 0 you don't have a matching y, so you don't have a y for this. So in the domain just exclude x equals 0. That's how you identify the domain when the graph is given. And so when it comes to these transformations, identifying the domain is also an important part. And then vertical shifting, then we did like a combination. When you have both vertical and horizontal or other types of transformations, what you should do is think about the simplest form, the simplest function you can think of, and then slowly make some transformations that you learned to obtain this complicated formula. Okay, so if they ask you something like this, first of all figure out the simplest place to start, and then go from there to here using the transformations we learned in this chapter. And another type of a transformation is the reflection with respect to axis. So basically if you multiply a given formula with a negative, it flips to the other side across x-axis. So if you have a function, let's say this one, if you multiply with the negative, it flips to the other side across the x-axis. And if you change like this, it flips to the other side across the y-axis. So see the difference. Here you have a minus, reflects around the x-axis. Here you have a negative inside, reflects around the y-axis. And again we did several examples like this in the class, and all those examples are there in the slides. So in case if you missed the last week lessons, you can always go through these slides and figure out the problems, and also you can come and talk to me if you have any questions. And also when you do these reflections, keep an eye out for the changes in the domain. Like for example, for this graph, the purple, the pink colored one, this is the domain, but for this one, this is the domain. Okay, and if you need the range, here this is the range, and here this is the range, this side, these y values. Here this is the range, this is the domain. Okay, range is all the y values, domain is all the x values, right? Okay, and then we did a couple of more transformations. Now this is the reflection. And after that, let's see, it flips across the x-axis and then the y-axis. And after that, we learned about vertical stretching and compression. So here, when you multiply with a number, so there's a difference between this and the other one. When you multiply with a number outside, let me take it, a screenshot. So when you multiply with a number like this, the graph will vertically stretch. It will vertically stretch. Vertical stretch means along the x-axis. It kind of stretch along the x-axis. And if you compress, if you decrease the value, it compresses. Okay, a very good way to visualize this is by using Desmos. Okay, so let's take the example they have given. So for example, let's take the square root, and to visualize that graph, just go to Desmos graphing calculator and draw y equals sqrt for the square root. You have this, and I'm going to put a variable a along with the slider. Here I start with 0 up to 5, and you can kind of give a step size, let's say 0.01. So you can move the slider. Okay, see what happens to the graph when you increase the value. See, it stretched along the y-axis. Just consider you are pulling, you hold the graph from here and move it upwards. That's why stretched along the y-axis. And if you decrease the value, it compresses along the y direction. That's the meaning of stretching and compressing. Here, this symbol says when a is small. Here, when you increase the value of a, here it's so small in the sense when you decrease the value of a. Okay, now the difference comes when you have this constant inside. Okay, let's take this one as well. So when you have this, you can see when the a value is inside and when it is decreased, this says a is decreased. Remember, when you have this symbol, it says decreasing the value of a, but it stretched horizontally. But see here, when the value of a is decreasing, it compresses vertically. So basically, if you have AFX, this is for the vertical compression and stretching. When you have FAX, that is for horizontal compression and stretching. But the difference is, for this one, for the vertical case, when the A value is decreasing, it compresses. But for this one, when A decreases, it stretches. And for this one, when A increases, it stretches. For this one, when A increases, it compresses. So the difference is here A is multiplied outside, here it is inside. Once again, you can check an example they have given in the slide, something like this, x cube. So let's go back to the Desmos. I'm going to hide this graph and I will have y equals x cube, and I will put an a here. See, when I increase the value, it compresses along the x direction, x-axis. When I decrease the value, it stretches. So they kind of work in the opposite directions. Okay, so those are all the transformations we have done. And what you should be able to do is, when they give you something like this, okay, you should start from the simplest form, and you should be able to transform it step by step like this into the given original function. Okay, we discussed a problem like this in the class, and if you were absent on that day, or if you need some more practice, just go through this problem slowly and carefully by understanding each and every step. The main criteria is that you should follow is, if they give you a complicated formula, think of the simplest function to start with, and then go from here to here using the suitable or the appropriate transformations we learned. Okay, and then when you have those transformations, you should know how to extract out the domain and the range of the new function just by observing the graph. Okay, so finally on Monday I discussed about other operations in between functions. Like if you have two functions, we have addition, subtraction, multiplication, and division. And on next week, I'm going to do something called composition, but that's not in the related to the exam. So we handled these four operations in between two functions. And so I expect you to know how to derive a formula. Let's say if they have something like fx equals, let's say x squared, and if this is gx is equal to something like x cube, you should know how to get the appropriate formula when you have things like f plus g. What is the formula for f plus g? That is x squared plus x cube, and so on. And another important thing is, you should know how to obtain the domain of these resulting functions. Okay, now here this was a function, this was a function, the addition, the result is also another function, so I need the domain of this function. Now for that, what we do is, we get the domain of this, we get the domain of this, and we get the domain of this, and we find the common points in between these two domains, and those common points will act as the domain for this. Same goes for all these other operations, but you have to be extra careful when you have a division. So if you are dividing the two functions, once again you follow this same idea of finding the common points, and then you have to take one more extra additional step, that is, now this g is the denominator, so what you have is f divided by g, and now you have to make sure to check gx equals 0 and to identify these x values which make the denominator 0. Okay, you have, I think, a question in here. It's on the other slide, so that's something you should have the practice on. Okay, so if you are finding the domain for a division, first of all find the common points in this domain versus this domain, find the common points, and then remove all the x values that make the denominator 0, and the resulting set will be the domain of f divided by g. You should only do that when you have a division. Other than that, for the other three operations, you just find the common elements, and that's it. For the division, once again, you find the common elements, but you take an extra step of removing the x values, which make the denominator 0. Okay, right. So that's all about everything I wanted to do for this review. But once again, I need to remind you that this is not enough. I mean, enough in the sense, if you only watch this video as the practice for the exam, that's not going to be enough. Okay, just use it as a good guideline. Do as many problems as possible. And if you have any questions, feel free to reach out. uh, have a good night. Well, now the time is 11:16, so have a good night. Or if you are checking it tomorrow, have a good rest of your day. Thank you for listening.